Good evening, everyone. Welcome to another session of Physics Unveiled. And in this session, we will be taking up one more problem that we have shown in our daily practice problem series. The problem is based on motion under gravity, and you can see the problem well before yourself. It is about a ball which is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. The height from which the ball is thrown is 25 meters from the ground. How high the ball will rise and how long will it be before the ball hits the ground. So I would like to solve this problem not using the values that has been given into the problem. I will just make it general so that in future, whatever problem you come across the motion under gravity, you can take the similar approach and solve it by yourself easily. So let us see. I think there is some issue. Let me. So suppose this is the tower, this is ground, and the ball is thrown from here. Upward direction at the velocity of u. So what we'll do, we'll just first of all take a reference frame, suppose origin in short. Suppose this label we are taking it as origin, and all the measurement that will be done in this direction will be taken at positive, and all the measurements taken in this direction I'll be taking at negative. Why? Because we'll be using the equation of motion by gravity, and where we can calculate the displacement covered, and for displacement there needs to be direction. So using this sign convention, the initial velocity, let the u we may write as plus u. Okay, let the height of the tower is h, which is giving here as 25 meter. Now ball will first go up to certain height. Suppose the ball has gone up to this height, and then it will come back. Okay, first this is the maximum height. This is maximum height. So what is the concept of maximum height? Maximum height is that point at which the velocity of ball is 0, right? So from the equation of motion, we know v equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration due to acceleration of motion, and t is the time taken to reach to that point. So, just replacing all this value with the value of problem, v equal to 0 for maximum height, u equal to plus u, it is given. Acceleration here is minus g, because g is always acting in the negative direction of our measurement. This is the direction of g. Okay, and t is the time taken to reach that maximum height. So time equal to, putting this value, we'll get time equal to u by g. Okay, now let's see. Now when ball will reach to, when ball will come back to this point, at this point, and it will be going downward, then total time of flight will be, total time of flight will be 2u by g. This will be twice of this t. Okay, this t. So in this time, ball will first go up. This is the t time. Suppose this is the t time taken, and this is the t time taken. Okay, so this t and this t, this will be 2t. So ball will again reach here, and since we can easily calculate that the ball, when ball will just arrived at this situation, it will be going downward with the velocity of u. So from here we can solve. Initial velocity is again minus u. Displacement is given, that is minus h. Acceleration is given as minus g. So we may use h equal to ut plus half at square. Okay. So we may just substituting the value minus h minus ut minus half gt square. So there will be equation like h equal to ut minus half plus half gt square. So it will be gt square plus 2ut minus 2h is equal to 0. So this time, this is the quadratic equation. You can see this is the quadratic equations. So from here we'll get the two values of time. Okay. So this time is the time taken by ball to reach ground from origin, right? So total time of flight now we may write as time as 2u by g from, and the value of time that we'll be getting from here. This is the total time of flight by the ball, right? And if you just want to solve this problem directly, then how you can solve it? See, in this case also, okay, let me take the entire approach in different format. Okay, so what we'll be taking, as I've told you, that from this time you'll be getting two values. Okay, so you must be getting one value of t such that it is covering the both the aspects, because ultimately the displacement covered by the ball from this point, from this very point, to this ground is minus h only. So we may directly put like how high the ball will rise. First of all, you have to find out how high the ball will rise. So you have to find out this maximum height. So maximum height we may calculate as v square equal to u square plus 2af. So since at maximum height, final velocity is 0, initial velocity is given u square minus 2gh. So h is h, you may calculate u square by 2g. This is the maximum height. Okay, so this will be u square by 2g. Now, how long the ball will take before it hits the ground? In that case, you can have two approach. You can write from starting that time, calculating the time from here to here, then here to here, that is 2v by g, and then you may calculate separately this part. Okay, this is the one approach. Another approach is this: you can directly see the ball has been projected from this particular point, and it is ultimately reaching to this particular point. So this is the effective displacement. So we may directly calculate h minus ut plus ut minus half gt square. Okay, plus u. This is the negative displacement h, and this is negative direction of g. So in this direction, we may write as gt square minus 2ut minus 2h is equal to 0. So from here also you can calculate a time which will give you the entire time taken by the ball to reach the ground. So what the general concept we have touched over here, this way you can solve this kind of motion under gravity problem. So what the concept that we have touched, again we are summing it up. You have to choose an origin. You have to put fix a direction of the positive and a negative direction of the vector quantities, and then you may use the equation of motion of constant acceleration, and you can have your answers. So with this, we are finishing this problem. Hope you have understood the concept of motion under gravity. If not, I'll recommend you to go to our playlist of kinematics, and there we have explained the concept as well. And at the same time, we have derived the equation of motion under the constant acceleration. You may have, if you just want, you can have a look at those. Otherwise, this problem is sufficient to explain the nitty-gritty of concept of motion under gravity. Thank you for your time, and keep liking our liking our material. Sorry, and subscribe our channel so that we'll have the better reach to more and more students, and You should also share the playlist, the videos and everything with your friends also, so that they can also get benefit. And you can post your comments as well to us, and we'll address that. Thank you.